in with class. Alrighty, so just to kind of review what we've done last time, yeah, we're talking about electrons still. So I'd like to just start by having us do a little practice one, for example. Let's start with calcium, and let's go ahead and figure out its electron configuration. You're going to want to get a periodic table out. We're going to be using one fairly often for today's class, so I would go ahead and get one of those out. And then in the meantime, start working on this. Aha, I have one too, somewhere under all the crap. Periodic table, yay! Okay. So calcium is number 20 for any of you who are searching for it. And so just so we remember, the electron configuration is, that's the 1s2, 2s2, etc. type thing. So I'll give you like 30 more seconds or so to go ahead and work on calcium. And then I'm going to go ahead and write it out here. So hopefully you're like writing along at home or something, just to make sure that you're keeping up with these vital skills. And also we'll talk about the exam in a little bit. I think we'll probably do it next Wednesday, since that's right before spring break. And I think that makes the most sense for everyone, so we'll probably do it then. But I'll let you guys know. Alrighty, so you guys should get for this one the following electron configuration. Hopefully we all got this one. Anybody have a question on this one? Yes, we are, Shalea. Are you guys able to see it? Okay. So yeah, Shalea, just double-click my name in the main classroom and you should see the video stream. Ooh, loading, that's not good. Okay, well, thankfully against Sample, at least it is recorded, so this will be up on YouTube later. I know that some of you, Josh has sent me an email saying that some of you are having internet outages and like kind of spotty internet right now, so hopefully that recorded one should still work. Yeah. So yeah, sometimes streaming uses a lot of bandwidth, yeah, so definitely everybody else can be, dragging things down. Okay, well, hopefully most of you will still be able to at least hear me, and worst comes to worst, you can just watch the video later. Not sure exactly what else I could do about that, so. But hopefully this is still better than Zoom from some of your other classes, so we'll see. Can you clarify your question, Robert? Like, you mean, like, how's it going to be, like, graded? Is that kind of what you're going for, or? Yeah, you guys are still doing the practice things on the textbook and the end of chapter quizzes. So we are finishing chapter 4 today. And we're going to start chapter 5. Okay, and while Robert is typing, Cassidy, did you have any specific questions about the electron configuration stuff? So for those of you who can see my screen, hopefully this should not be new information. Okay, yeah, we're going to spend some time today, Robert, working on that. Okay, so I see. Okay, so we'll go ahead and step back then a little bit. So hopefully everybody has a periodic table, either a printed out one or access to one on their computer somewhere or their phone or whatever. Let's see. I think everything.
I'm not sure.
The Alexa just got activated. Okay, so periodic table time. Okay, so you guys can hopefully see this. Okay, I'll do that later, Robert. Or let's see. This should be unmuted for everyone, Robert. I'm pretty sure that would. Yeah. Zoe, it's still in the group activities channel. If you go there and go to the top, the worksheet is still there, so you'll have access to that for forever. Should have known Robert would do that. Okay, cool. So, back to calcium. Oh, hold on, we got Shelby has a question. Let's see. The suspense is killing me, Shelby. Or not. Okay, well, anyways, back to chemistry, I guess. So, periodic table wise, calcium is right here, right? So we're going to want to identify I like to start backwards. So we see that calcium, do we remember which blocks of the periodic table there are? There should be 4 blocks, right? We have the sorry, I'm working mirror image. This is the S block here. We have the P block on this side. We have the D block in the middle and the F block down here. Hopefully none of that should be new for you guys. So, which block is calcium going to be in? Yeah, Robert, you got it right. It's the S block. Right. So, and then we also want to look at what is the period that calcium is in. The period is the number, the shell number that it's going to be in. Not quite, Robert. The big number at the front. Yeah, it should be 4. So calcium's in the 4th row of the periodic table. So 1, 2, 3, 4. 4th row. So, Shalea, the video should be on. If you can't see it, I would recommend restarting Discord. That usually will help it. Like Robert says, that's probably the best thing to do. Or yeah, you can just disconnect, reconnect. You can try that. Okay, but again, the video will be on. So, we can see that calcium is in the S block. It's particularly got its last electrons in 4s. We know that because that's where it is on the periodic table. So, we know for sure that this thing is going to be in 4s. Okay, so we also now want to figure out what the last electron is going to be. So I think this is what you were talking about, Robert. Is it going to be 4s1, 4s2, 4s3? What is this one going to be? I mean, I guess I have the answer up there, but yeah, it should be 2 because of the column. So Shelby, we always want to do these in order. So we always are going to talk about them in terms of lowest energy to highest energy. For this particular order, from 1s to 4s, it's in this order exactly. It's going to be easier, though, if I show you on the periodic table how this is going to work. So then let me step another step back. Let's go ahead and look at the periodic table itself. So here is my beautiful artistry. Let's see, something like this. I guess just a little more, and ta-da. And we've got some other stuff down here. Cool. Okay, sounds good, Tiffany. So, I'm just going to divide this into blocks. We remember this is the S block. P block, D block, and F block. This we did on the worksheet last time. These are just what you're going to have to learn. We're going to see, let's use green. We're going to see that 1s is going to be hydrogen and helium at the top there. We're going to have 2s as the second row. Okay, if a lot of you are having trouble, I will try disconnecting and reconnecting as well. That may help you. So I'm going to stop the stream for a second, and then I'm going to restart it, okay? Okay, so I've just restarted the stream, so hopefully that should be up for you guys. Okay, I'm going to give you guys like 10 seconds to click it. Hopefully you'll be able to see. Yeah, so if you're looking on the left side, you should see my name with a big red thing that says live. And you just double click that and it should pop up the video for you. Alrighty, so hopefully that has helped some of you guys out. So continuing, so 2s was the second row of the S block. We're going to see that 2p is the second row of the P block. I'm going to go ahead and erase these just because they're going to get in our way. We're going to see the third row is 3s and 3p. The fourth row is going to be 4s and 4p. But something horrible happens here, for you at least. It's not actually going to be 4d that is in the middle there. It's actually going to be 3d. The reason for that is because d electrons are going to have typically higher energy than p electrons will. And so we're going to see that, that s electrons will. And we're going to see that those transition metals are going to do pretty funky things because of the being in that d block. For now, everything in the d block that you see is going to be its row minus 1. So that means the first row of the D block, even though it's in the fourth row of the periodic table, is still going to be 3D. I know that can be a little bit strange, but this is just kind of how it is set up. Okay, 4p is no different than the rest of the p's. So if we continue on, we're going to see we have 5s and 5p. And in between those, the second row of the transition metals is going to be 4d. I'm going to have to make my periodic table just a little bit bigger. Sorry, guys. I'll just extend that down a little bit. If we keep going, yes, sig figs to the alphabet. We're going to have 6s. Sorry, let me make that in green for you guys, just to be consistent. We have 6s. 6p, and then 5d in between. And then the last one is 7s, 6d, and 7p. Alright, so those are the 7 rows of the periodic table. We're not going to touch the F block just yet. I know that this is a bit strange. But if we look at, for example, barium on the periodic table, awesome, Shalea. If we look at barium, that's number 56. Can anybody find that on the periodic table for me? And then tell me which particular subshell that's going to be in, or rather orbital. Barium. Ba. Yeah, so it's going to be in it's 6th row, right? And it's in the S block. So we're going to see that barium is going to be somewhere in there. Yes, well, 6s. Wow, that was a couple of years ago now, wasn't it? So, barium is going to be right there. Okay, I'm going to put a little star on, how about blue, so we can see. So barium should be like right here. So that's the second one of the S block, therefore it is 6s2. Indeed. Okay, so if we go, well, let's go ahead and find calcium now. Where's calcium going to be in terms of subshell? Yeah. Yeah, absolutely right. So calcium is going to be here. I'm going to go ahead and erase barium so we don't get confused. Whoops. Okay. Great. Okay, cool. So with that in mind, we know that calcium is going to be 4s2 as the last one. Its last electrons are in 4s2. Okay, so where it is on the periodic table will tell you where its outermost electrons are. Okay, so hopefully that should be okay. And so what we're going to have to do is now move through the periodic table backwards, filling in everything that we go. Yeah, so, I mean, it's kind of the group and period, Melissa. So it's in the second group, group 2, and the fourth period on the periodic table. So it's going to be 4s2 is its last orbital. Okay, cool. For S, yes. Alrighty, so if we're looking backwards, so calcium is number 20, right? So potassium is also in 4s. Yeah, we're going to work backwards. So what comes before potassium on the periodic table? Argon, right? So argon, we're going to see, is in which block? Yeah, argon is 3p. It's not going to be 3p1, Robert, but it's going to be in 3p. So we know that the orbital right before 4s, as we're moving backwards on the periodic table, is 3p. So argon is right here, right? It's the last one of 3p. All right, and how many electrons can the p subshell hold? Yeah, P can hold 6 overall, right? And if we count, if we go from aluminum to argon, we're going to see there's going to be 6 elements there. And since we're going to see that calcium is past all of those, we're going to use all of the 6. We're going to see that everything up until our last one is going to be completely full to maximum capacity. So everything that's in the S block will have 2. Everything that's in the D block will be 10. 6 for the P block, and 14 for the F block. Right now we're not touching the D block or F block, so forget about them. What comes before 3P? Not quite, Robert. Yeah, I like Manuel's answer. So if we look, so aluminum through argon, all of those were in 3P, right? So aluminum is the start of 3p, and argon is the end of 3p. The one before aluminum, then, is magnesium, exactly. And so we look at magnesium, that's now in 3s. So we're going to go ahead and write 3s2. Remember, we're going to want to fill up all of these orbitals that are going... Yeah, we're just going backwards. We're taking the periodic table and just moving back each block at a time. That's awesome, Zoe. Okay, so now before 3s, what's that going to be? (2p), exactly. And since we know p's can hold 6, we're going to go ahead and put all 6 electrons in there. And if we keep going backwards, we're going to go through 2s and 1s. Yeah, Robert, what about 2p? Yes, sodium is in 2s. I'm sorry, 3s. So the 3s2 is both sodium and magnesium. So that 2 on top tells us we've gone through both elements in the S block. The 6 on top of the P's tells us we've gone through all 6 in the P block. It's funny watching the little light bulbs come on in chat. Okay, so hopefully this makes a little bit more sense. Yeah, Elza. So as we go through this, we're going to go through every element before calcium, essentially. And so going through that, we're just going to kind of group them as blocks. So going through this periodic table thing, yeah, so this is my little shortcut. So I like little shortcuts. So calcium, I'm so sorry, working backwards is just killing me. So calcium is here, right? So that's 4s2. 4s2 is everything that's in the S block. So we've already accounted for potassium. Okay, because we've already put 2 of them on there. Alright, if we go back now, keep going back, we see argon, which is in the 3p block, right? And we know that calcium is after all of these elements in the p block here. So we're going to say that all 6 of the 3p elements, we're passing all of them. Okay, so we're going to put that as 3p6. That's this part. All right. Hopefully that makes sense. And then, so now we've gone through everything in 3p, which brings us to aluminum. Not yet Sarkis. All right, and so now we're going to keep going. We get to magnesium and sodium. That's the S block, right? And that's the 3s in particular. So we're going to put 3s2 to account for both of these guys. And after that, now we keep going back. Now we're at neon. And we see there are 6 elements in that p block that we're going to have to account for. So we're going to go ahead and say 2p6. That'll get us back to boron. Then we have to go back to beryllium and lithium. That's going to be 2s. So we're going to say 2s2 to account for both of those. And then the last one we have helium and hydrogen, which are the 1s2 elements. Okay, so basically 4s2 is incorporating every single element from calcium and from hydrogen through calcium in that order. It would be 3p3, Cassidy. You're absolutely right. So we're going to fill up every single thing that comes before our element. We're going to notice, though, that let's go ahead and do phosphorus. Melissa, helium is just part of the is special case. Hydrogen and helium are just part of S. They're just 1s2. So that's just this kind of special thing on the top there. Hydrogen and helium are 1s, and that's just a special case. So remember, because there's no 1p, doesn't exist, so that's why. Okay, let's go. Let's go ahead and do. Oh my God. Okay, wow, Robert, you pulled a Manuel there. Wow. Yeah, I'm sure you were. Not quite, Robert. Cassidy actually has this one correct. Let's go ahead and do phosphorus. Yeah, Ingrid, you're right too. So if we look at phosphorus, we have our periodic table here. Where does phosphorus end? We know for sure it's in the P block. We see that it's the third row of the periodic table, which tells us it's 3p. And so, as Ingrid and Cassidy have already kind of intuited, we're going to see that phosphorus being the third element in that P block tells us that the last part for phosphorus should be 3p3. Okay, so we're doing phosphorus now. So 3p3 is the end. So that means we're going to have to fill in everything before 3p. So we're going to just keep going. Orange this time. We're going to go from here, from phosphorus. we're going to go backwards, 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 and backwards. All right, so it looks like we still have to take account of 3s. And remember, everything before 3p is going to be completely full. So we're just going to put the maximum number of electrons we can. We know that s can hold 2 electrons. The 2p before that can hold 6. The 2s can hold 2. And the 1s can also hold 2. Yeah, exactly. That's correct, Robert. Okay, so you're going to be able to use the periodic table to kind of fill these things out for you. It'd be like that sometimes, don't it? All right, let's see what Melissa's got to say. Correct. Exactly. We counted the first 3 of the P block. So really the only thing that's going to be different for each element is that last set. So we only have to think about what the last electrons are going to be, and then everything else before it is going to be completely filled. So let's do something just a little bit more complex. All right, just to mess with you guys. Now that you think you know it, I'm going to just destroy your confidence. No, that's not my intention, but we have to work through tougher problems in order to understand the entire concept. Okay, so I'm going to go ahead and give you another element. Here we go. How about we do selenium? Selenium is number 34. Let's see, you guys can find it. I want you to type out what the last electrons are going to be for selenium. I want the subshell and then the number of electrons. Yeah, looks great. Great, great, great. So, you guys are absolutely 100% right. We have 4p4. Excellent, 100%. Alrighty, so if I come back to my periodic table that I've drawn on 50 times, oh, sorry guys, it's been completely destroyed. Okay, so selenium is here-ish, right? 4p4. Yeah, so we're going to look what's before 4p. And Robert is absolutely correct. Before 4p is the 3d. Okay, does everybody see that 3d is before 4p? Alrighty, so that means we're going to put 3d right before it. And Robert is correct. Since the d block can hold 10 electrons, we're going to go ahead and fill it up completely. And now we're going to just keep working backwards. So what is before 3d? Yes, very, very good for us. Okay, and since it's completely full, we're going to have 2 electrons in there. And then we're going to just keep going backwards. Exactly. Yeah, you guys look like you're kind of getting it. That's good. So you should get 3p6. 3s2, 2p6, 2s2, 1s2. All right, just for time's sake, I'll do the last bit for you. Okay. Nice, nice. Science, indeed. Logic, magic. Alrighty, so I understand that this is time-consuming because you have to look at all of these and then count the blocks and everything, and it can be fairly tough. Lightbulb, this is awesome. I'm glad you guys are getting it. So this will definitely help you guys out for the next chapter. So So, no, it'll be a shortcut for you guys. So, alright, how about we do, let's see, how about we do, you know what, we already did calcium. I'm just going to write calcium again down here for you guys, and I want to show you something. Oops. 3s2, 3p6, 4s2. We're going to see, is there anything that selenium and calcium have in common? Anything at all? Yes, that's true. But looking at these electron configurations specifically... Get out of here, Robert. I mean, I understand. You are right. This is true. Yes. So, I understand what you're going for, Robert. I was just teasing you. So, yeah. So we see that, you know what? Let me just change this, just to make it a little bit easier for us. I'm going to make this potassium instead. And if I do that, I only have to change this guy to 1. Okay, just so that it's a little bit easier for us to see. So, Arpin, you were right before, but now we're going to see that these guys are all the same. So, we are going to have a shortcut for this. Because we're going to see that everything in that fourth row is going to have all of these the same. From 1s to 3p, they're all going to be completely filled. So, we're going to see, what is the electron configuration that ends in 3p6, by the way? What element is that? What is 3p6? Yeah, it's argon, right. So, we can say that these guys, selenium and potassium, are both argon with some stuff attached to them. Okay, so we can see that selenium, after that 3p6, is going to be 4s2, 3d10, 4p4. And potassium is going to be the same as argon plus 4s1. Yeah, it's the shorter version. You're absolutely correct. Yeah, seriously. Look at how much easier I've made this for you guys. Yes, absolutely. So I will presumably be able to ask you either one, of course. We call this one the noble gas configuration, just because we're looking at the last element of the previous row. So we saw that selenium and potassium are both in row 4, fourth period of the periodic table. And we see that the noble gas in the third row is argon. So we can say that for sure everything in the fourth row will be argon plus something else. All right, and if we're looking at the fifth row, we're going to see it's krypton plus something else. So let's go ahead and do that. Let's go ahead and... Ooh, let me give you a tough one, okay? How about we do zirconium? Oh my heavens. And we can go ahead and use the noble gas one for this. Let's find zirconium. Oh my heavens, that's number 40. So, if we're going to use this noble gas shortcut, what row is zirconium in the periodic table? It's in row 5. So, we're going to use the noble gas from the fourth row. which is going to be Krypton, right? So we're going to start with Krypton. So element... Oh my goodness, how embarrassing. Okay, there we go. In row 5, we use the noble gas from row 4. And now we just have the extra stuff. Alright, so what is zirconium's extra stuff going to be? Where is zirconium's last electrons? Samvel close. Shelby has the absolutely correct answer. So does Zoe. Yeah, so the last electrons are 4d, right? We know this because remember everything in the d block is one less than the row number. So you're correct, it's the 5th row, but it's going to be 4d. Okay, so that's just something you're going to have to remember, is that the d block is one number less. Yeah, it's 4d2, right? Because we see it's the second element in the d block. So for sure, we're going to have 4d2. All right, does that make sense to everyone? Great. Okay, and then so now we just have one more thing to put, and Zoe and Shelby have already done it for us. We also have to put on 5s2. All right, hopefully this makes sense. Fun fact for you guys. Notice that all of this stuff is all core. Okay, and then our d electrons are also going to be core. All right, so this allows us potentially to see the valence electrons a little bit more easily. Okay. Shall we make this one step more difficult? And that's the last step, I promise. Well, you don't really have a choice. So, sorry, Shelby. The last thing. We have a part of this that is missing, right? We haven't talked about one particular section of this. Alright, and just to be nice, I will not ask you for this one. Oh my god. Okay, hold on, let me read what Robert has written. You are correct, Robert. Very good. So that would be the expanded or standard electron configuration. My goodness, you wrote a novel. Okay, very nice. Okay, so we have ignored part of this, haven't we? We have the dreaded F block. Oh no. Fun fact, we have 4F and 5F. Alright. If we look at our periodic table, again working backwards, what's the number of the element? What's the atomic number of the first one in the top row of that F block? Sorry, I'm out of the way. Look at your F blocks. What's the atomic number? So symbol, just the atomic number. It's 58. Yeah, cerium, right. So if we're looking at 58, we have to find 57 for the one that's right before it, right? Where the heck is 57? You can do it, Robert. 57, yeah. It's going to be lanthanum, right? Yikes. So these two rows of the periodic table are actually going to come in after lanthanum and actinium down here. Okay, so if we really wanted to do this correctly, technically our periodic table would look like... Oh my goodness. Okay, we've got boom, 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 boom. This is technically what the periodic table looks like. Alright, so we have our S block, our F block, our D block, our P block. All right, so technically we have, let's see, we have barium, lanthanum, cerium, etc. And then we get into hafnium down here. Yeah, it's going to be 4F1. So that's just, I just want to introduce this to you so you guys will see it. But we're going to say that just like how the D block was one less than the row it's in, the F block is actually two less. So even though cerium and all of those technically belong in the sixth row of the periodic table, those electrons are going to be 4F. Alright, so if we were to do something like lead, for example, I'll do it for you just to illustrate the point. We're going to see that lead is going to start with xenon, because that's the noble gas from the last one. And lead is going to end in 6p2. Yeah, I know, Zoe. This is why it's awful. Yeah. It's awful. I'm sorry, but no way to get around that. However, lucky us, we're going to see that we can do this. So if we go before lead, we get to thallium, and before thallium is mercury, which is in the D block. So we're going to actually have 5D10 before that. If we keep going, we get to the F block, right? Which is going to be 4F14. And before our F block is 6S2. So I'm not going to ask you guys to do anything that involves the F block, but I want you to be aware of how we would talk about it. Okay, so hopefully this is not too crazy. Like, this should be... I mean, you're going to have to do it in 101, so sorry, but you'll get used to it. Alrighty? Fun. Exciting. Any questions on that one? Like I said, I'm not going to necessarily test you on this, but just wanted to show you what it looks like. Sure. So the F block, you're correct technically, Zoe. Lanthanum is 5D1, and cerium is going to be 4F1. But since we typically write the blocks as full, we're just going to, okay, let's look at it. So we have, where were we? We have hafnium through mercury down here, and then thallium and lead. Oh my god, Samuel, yes we can. People are trying to kill me. Okay. Alright, Zoe, so let's do this one first. That's just how we do it if we're going to use the noble gas shortcut, also we just put it in brackets. Just to illustrate that we have the same electron configuration as xenon, and then we're going to go forward. Okay, so lead is here, which is going to be 6p2. So moving backwards, we're going through 5D, and then going backwards, my god, this is getting so messy, I'm sorry, but that is 4F right there, and that's 6S, and then we're at xenon, yay, which is where we started. Alright, so it's really nothing new necessarily, Zoe, it's just putting in that F block before the D block. Hopefully that makes a bit of sense. Alrighty. So while Zoe is typing, let's go ahead and do that. So we know... So I think it may be easier to remember that the D block is always one less and the F block is always two less. But if you just want to remember the numbers, I guess that would work too. Okay, so this part is already done. if we want to expand this to standard notation, we were going to have to figure out what xenon is. We're going to have to spell out xenon's electron configuration. Okay, so let's just put all this stuff at the end and go ahead and write out xenons. Also, I'm just going to go ahead and mute you just for right now. Okay, just because your mic was open. Okay, so if we want to do xenon, that's okay, Elsa. No, don't worry, it happens. If we want to do xenon, what is xenon's last electrons going to be? 5p6, right. So I'm going to just say all this stuff goes here, and before that is 5p6. Does everyone see why xenon is 5p6? Yeah, thankfully S and P block ones are easy for us because it's the same as the row. So before 5p is going to be what section? What subshell is before 5p? 4d, exactly. So we're going to have 4d10. And before that, five s2. You're absolutely right. Oops. And I'm going to just go ahead and write the rest for you guys, just in the interest of time again. All right, so if we want to write the whole thing out, it would be all of this stuff and then add on those last bits. Yeah, the F block is going to throw you off. I understand. But that's the F block's job, to be horrible. So, yeah. Like I said, don't worry about the F block right now. I just want to put it in your brains so that when you hit 101, you'll be like, oh, okay, I vaguely remember this. Yeah, pretty much. That would be how to do it. Alrighty, so hopefully this is making a bit more sense. From what you've typed so far, it does look like that's the case, so I'm glad. You will have homework on this eventually, so that would be good. Oopsies. 1 second. You can use the noble gas version if I don't indicate that I want the full one. So you're welcome to use either one unless I specify I want noble gas configuration or I want standard configuration. Standard is the one that has all of them, so that would be standard down here. And then the above one with the xenon is going to be noble gas shortcut, okay? Okay, so Robert, the reason for that is just because the F block, if the periodic table did look like this, it would take up a whole lot of space. And so just in terms of space-wise, it's easier for us to just extract those 2 rows and stick them at the bottom. So technically they should be, I understand, but technically they should be in line with everything else. Yeah, exactly. So it's just the difference between the last electrons and then the noble gas. By the way, just so we all know, noble gases are the far right elements. You know, helium, neon, argon, krypton, xenon, and radon. And okinason. Okay. Yes, you could say that. Yes, absolutely. That is 100% correct, Harbin. All right, anybody else have any questions on this? Okie dokie. So, in that case, Arpin brings up a good point. We saw that this was xenon, right? And all of this... let me do this in black, actually. All of this was Krypton. Excuse me, Krypton. Right? And technically all of this is argon. Just going to get rid of that. And all of this is neon. And this is helium. Right? So we see these noble gases, with the exception of helium, all end in P6. Right? We're going to see that if we count the valence electrons of all of these, let's see if we can do it. Let's look at what's the easiest one for us? Let's do this one. Okay. So if we look at this noble gas, which was argon, how many valence electrons are in argon? Not quite, Samville. It's going to be a little bit more than 6. Not quite 12. A little bit less than 12. You guys are just throwing out random numbers. Oh my heavens. Okay, so Shelby is correct from all your random guesses. So the number of valence electrons, we're going to look at the outermost shell, right? That's the biggest number. We're not looking at the 4s1, right? Because that's potassium. We're just looking at argon, which is this boxed thing. Alright, so the last shell of argon is 3, right? So it has 3s2, 3p6. It has 2 electrons in s, and it's got 6 electrons in p. Put those together, that's 8 valence electrons. Okay, going back down, I know that this is totally all over the place. If we look at xenon, let me highlight it in red this time. Xenon, oh, well, xenon is technically the whole thing. Hold on. Okay. Okay, xenon. There's xenon highlighted in red for us. How many valence electrons does xenon have? Aha, Samville's right this time. Why is it not 18? That's correct. So remember, Zoe, that because this D, the group of D electrons, is at 4 in front of it, those are still going to be core electrons. Yeah, so it's just going to be the stuff from the 5th row. So that's going to be these two guys put together, which gives us 8 valence electrons. Alrighty. How about, let's do neon. Here's neon for us. How many valence electrons does neon have? Not quite, Elsa. Yes! Very good, very good. So remember, we always want to include everything that's in the outer shell. Okay, which means 8 valence electrons. Alrighty, how about, which one haven't we done? Krypton. Okay, here we go. I'll write out Krypton for us. And I'm going to just go ahead and use the shortcut. Okay, because we know everything in the shortcut is going to be core, right? So we don't care about the core. Alright, how many valence electrons? Are we just guessing? Because you guys are absolutely correct. Very nice. We always look at the outermost one. That's the biggest number shell we have. Okay, which, guess what, is 8 valence electrons. So are we seeing a pattern here? Yeah, so we're going to see all the noble gases, with the exception of helium, have 8 valence electrons. Alright, easier one for you. Let's look at these ones, just so we can see what is the noble gas configuration of all 3 of these. Sodium is number 11, 19, and 37. I'll just write those out, because I know you guys will obviously not memorize those. So please don't, by the way. Don't memorize atomic numbers. I'll give you a hint. These are all going to be real similar. Noble gas, please, Robert. But yes, you are correct. So I'll just write that one out for you in noble gas. I like the idea, Zoe, but that's just ever so slightly incorrect. See, because if I write it out, yes, exactly, S1. Yeah, they all have the same. Yes, very good, Tiffany. Alrighty, so, as Zoe has pointed out, they all end in S1, right? If you were to count the valence electrons of these guys, how many valence electrons would each of them have? Yeah, they all have 1 valence electron. 7? Elsa, where did you get 7 from? So if we think about sodium, for example, if, like Robert already wrote out for us, we only are counting whatever is in the last one, the biggest shell number. So we look at these, we look at these numbers here at the front. We have a 3, a 2, a 2, and a 1. And the biggest of those is going to be 3. So we're going to look at everything that has a 3 in the front of it. And since those p's are actually in the previous shell, those are not going to count for valence electrons. We saw that with argon, we counted the p electrons because they were both 4. They have the same number. But this case, the p electrons are in a different row, so they're not going to count. Alrighty. Sorry, that's a V. Let me just fix that. Okay, cool. Alrighty. Can anyone guess? So everything in group 1 Remember, groups are the columns of the periodic table, the vertical things. In group 2, how many valence electrons are they all going to have? Does anybody have any idea? Yeah, they're all going to have 2. So if we just take an example, we already did calcium. We can see that that's argon 4s2. So we're going to see that there's 2 valence electrons. We're actually going to see that everything in each group will have the same number of valence electrons. So calcium and magnesium and beryllium and strontium and barium and radium will all have 2 valence electrons. Alrighty. If we look at, how about sulfur? I'm just going to write it out for us here. Sulfur is going to be 3s2, 3p4. How many valence electrons for sulfur? 6, right. Alright, fun fact, what group is sulfur in, number-wise? 3. Group, so at the periodic table there's these numbers at the top. That's what I'm talking about. Like these ones, oh, I'm sorry, I'm on the other side. These ones. See 13, 14, 15, 16, 17, 18? Okay, so we're going to see that groups 1 and 2, group 1 will have 1 valence electron. Group 2 will have 2 valence electrons. We saw that group 18 had 8 valence electrons. We saw group 16 has 6 valence electrons. Can anybody guess what oxygens, or no, fluorines would be? Something in group 17? Yes! So we're going to see group 17 has 7 valence electrons. And guess what? Anything in group 13 will have 3 valence electrons. Alright, 14 will have 4, 15 will have 5. Alright. How about groups 3 through 12? How many valence electrons are those going to have? We're going to take our break shortly, don't worry, by the way. I've got a hint for you. We did one of the transition metals earlier. Something in the D block, somewhere in this mess of stuff. Or maybe not. Didn't we? Ah, yes, we did. Yeah, I like John's answer. So, zirconium was one of the ones we did. We saw that this was its electron configuration, right? I'm talking about this stuff. That's zirconium, which is one of our transition metals. We saw that it's going to have just 2 valence electrons. Okay, because remember that d electrons are always in the core. So all valence electrons will have 2s, something s2 valence electrons, and that's it. All transition metals will have 2 valence electrons. Alrighty? So we saw 14, 15 will have 4 and 5. So it should be easy. Any of these kind of big columns in the periodic table will tell us how many valence electrons it has. So the first column, 1 electron, 2 electrons, 3 electrons, 4, 5, 6, 7, 8, except for helium. Remember, helium only has 2. Okay, that's the only one that's an exception. All right, let us rest your exhausted brains for a few minutes. When we get back, we're going to start talking about more periodic table fun. Okay, so go ahead, take 10 minutes for a break. I will stop the recording. And